3.3, Properties of Logarithms. When we start looking at properties of logarithms, I really like to connect them back to exponential laws to help us remember. So our first exponential law that I want to look at is when I have two powers with the same base and I'm multiplying them, I add my exponents. So it turns out it's possible to take the log of two things that are being multiplied, so in this case log of a times b, and we can break those apart with addition, log a plus log b. So hopefully you can kind of see how that's connected. So if I have multiplying with logs, I break them apart with addition. And the next one we'll look at is division. So if I have two powers being divided that again have the same base, I have x raised to the a power, x raised to the b power, I subtract my exponents. So here when I have the log of two things that are being divided, I can break those logs up with subtraction. Notice I write the word log twice. I have log of a minus log of whatever b is. So last one is our power to a power property. If I have x raised to the a power and then raised to the b power, I multiply those together and I have x raised to the ab power. And then over here, if I have log of a raised to the b power, I can take the b and I can multiply it in front. So I have b times log a. So hopefully this helps to help you learn the logarithm laws by connecting it to exponential. So these are the three that we really are working on memorizing today. And we're going to look at a lot of different problem types that are going to help us learn them, that are going to apply these laws. So here's our first one. We want to take the logarithm of each number. In this case, we have 96 and we have 32/9, and we are going to rewrite them solely in terms of log 2 and 3. So that means we're going to be taking, like for the first one, 96, and breaking it down into 2s and 3s, and then trying to use those log properties to really separate it out. So I happen to know that 96 is divisible by 3, and this is not the only way to start this. It just seems like an easy way to me. So 3 times 32, and I know that 32 is 2 to the 5th power. I'm going to put parentheses just so I'm really clear. So because the 3 and the 2 raised to the 5th power are being multiplied, I can break this apart by adding those logs. So log 3 plus log of 2 raised to the 5th power. And then anytime I have an exponent like this, I can multiply it in front of my log. So I always circle and draw that arrow because I just find that it helps students remember what I'm doing. So log 3 plus 5 log 2. And we're all set. We have them broken apart. I don't have any more multiplication inside. Everything says log 3 or log 2. It's okay that I have a 5 in front. So in the next one, I have a fraction. I'm going to go ahead and break the 32/9 apart using log 32 minus log 9. 32 is 2 raised to the 5th power. 9 is 3 squared. And then again, we're going to take anytime we have those exponents, think of our power to a power, and we are going to multiply it in front. So 5 log 2 minus 2 log 3. The next problem type, we're going to actually look at simplifying some logarithms or evaluating, either way, but we're going to use these log properties to help us. So for the first one, I know that a third root is really 32 raised to the 1/3 power, and that 1/3 can go in front. And I know that 32 can be written as 2 raised to the 5th power. And when I have log base 2 of 2, I know that I'm just going to be left with 5. You don't have to cross it out again. It's just some of those weird things I do that help kids remember. But we have a property that says when it's base 2 and then this base is 2, we're just left with that exponent 5. And then 1/3 times 5 is 5/3. So there is definitely more than one way to evaluate this. This is just to show us a new way and get us kind of thinking about how these log properties work. On the next one, I can take both of these exponents and then multiply them in front with the coefficients. Since there was already a 3 there, the 3 times 4 would make a 12 times the natural log of e minus 4 times the natural log of e. And then these are like terms now. I can subtract. 12 minus 4 is 8 times the natural log of e. But if we really think about it, we remember that natural log is really base e. And e to the first power would be e. So whenever these two match, remember we just have a 1. So now I have 8 times 1, which is just 8. For our third one, we're going to work on expanding. So now we're using these log properties to break logs apart. We want everything to be the sum and difference of logs. We shouldn't have any exponents anymore. So b cubed and a to the fifth are being multiplied. So let's do that. Natural log b to the third power plus natural log of a raised to the fifth power. And then we know anytime we have an exponent, it goes in front. So 3 times the natural log of b plus 5 times the natural log of a. All right, all set there. No more exponents. We don't have logs of anything being multiplied or divided, so we're all set. We've simplified as much as we can. Actually, we wouldn't really call it simplified, would we? We call it expanded. Simplified is when we're trying to put like terms together and make things not so long. So expanding here again, log of 2x minus 3. I have to have parentheses here so I know it's of the whole thing, minus, because I'm dividing, log of 3 times the fourth root of x. So let's see. The log of 2x minus 3 I have to keep because I don't have any rule for breaking apart subtraction, and that's the part I'd have to deal with first. But I do have a 3 times the fourth root. So because I have this minus sign in front, I'm going to have to distribute that to everything. I'm just going to do brackets here for now while I deal with this part. So this would be log 3 plus, because these are being multiplied, log of the fourth root of x. And then my fourth root is really x to the 1/4 power. So log 3 plus 1/4 log x. So I took that power and multiplied it in front. Sorry, I did that so quickly. You do a lot of these and you really don't need to show work. And I forgot my 3. So minus log 3, I'm going to distribute the minus sign to the 1/4 of log x. And there we go, we're all set. So if we are working expanding, you know what's coming next. We're going to work backwards. We're going to work at condensing. So we're going to condense it so we have a single logarithm is how they always word it, so that we just have the word log written once. So anytime I have a number in front, it's going to become an exponent. So we go do that first. We're kind of doing the reverse steps of what we did before. So log base 4 of x to the 1/2 is just a square root minus log base 4 of the quantity x minus 2 squared. And then because there's a minus sign, I would want to put these now together as a single logarithm in a fraction. So log base 4 of, in my numerator, I have square root of x. In my denominator, I have the quantity x minus 2 squared. For our second one, same steps again. Coefficients will become exponents. So natural log of the quantity x plus 1 raised to the 5th power plus natural log of x to the 6th. And then I need to now, because I have a plus sign here, I'm going to be multiplying the x plus 1 to the 5th and the x to 6. And we really like it when the 6th power is first, so I'm going to write it that way. And we now have them as a single logarithm. We now have a formula for change of base. So we know that we have base 10 and we have base e, natural log, on our calculators. But sometimes we are given different bases and we need to be able to evaluate them as well. So we are going to use this to change to a base that we can use a calculator for. So use this to change to a base, and we would say either 10 or e. that we have a calculator for. So if I have log base 2 of 3, this is saying that log base, that goes in the denominator, this part here goes in the numerator. So this is whatever base I want to use. I'm going to use base 10, so that would be log of 3 divided by log 2. We could also use natural logs. That would be natural log 3 divided by natural log 2. So that's how that works. This one that's written that's larger, you do log of that one divided by the log of that smaller written number, the base. And if you were to evaluate both of these, you would get the same exact thing, which is kind of cool. So we're going to actually practice using that change of base formula now. And I know this is nice because I can give you a decimal to check your answer with. So for this first one, if it's log base 6 of 4, log of the big number would be log 4. When I say big number, I mean the number that's written big over log 6. And you will find that that is approximately equal to 0.77. So we could use base 10. We have that on our calculator. We could also use natural log. So natural log 4 divided by natural log 6 will give you the same answer. And you might want to check that yourself. This one we can do the natural log of 8 divided by the natural log of 1/3. Or again, we could do log 8 divided by a log of 1/3. You're not doing both, you're just picking one, okay? I just think it's good for us to remember that they're both the same. They'll have the same ratio. So negative 1.89. So it's not that natural log of 8 equals the log of 8. It's that the ratio of those two is going to be the same. So I think that's one of those finer details that we need to remember this year. That's it for our 3.3 notes.